Now just look at this question. This is an extension to the previous question. So the data is the same, and one more question is given on the based on the same data. Now here is, let the clock cycles required for the various operations be as follows. Okay, the question, the data that is given in this question is, let the clock cycles required for the various operations be as follows. That is, register to memory transfer 3 clock cycles, and add with both operands in register 1 clock cycle, and instruction fetch and decode will take 2 clock cycles per word. Okay, for executing these instructions, he's showing the number of clock cycles that are required for each and every instruction. If it is a register to the memory transfer, all it takes is 3 clock cycles for executing this instruction. If it is an instruction with 2 operands that are getting added, and then it takes 1 clock cycle. If this instruction has to be fetched and decoded, that requires 2 clock cycles per word. It is not per instruction, it is per word. Okay, and so now the question is, what is the total number of clock cycles required to execute this program? Okay, the total number of clock cycles required to execute this program, let us calculate and count. What we'll do is just identify the type of each and every instruction. The first instruction is register to memory transfer, right? A register to memory transfer, which takes how many clock cycles? 3 clock cycles. The second one is also register to memory transfer, because the memory of R1 will get transferred to R2. This is also a register to memory transfer, which takes 3 more clock cycles. This is addition with both operands in the register. If it is addition with both operands in the register, it just takes 1 clock cycle. This is add with operands in registers, which takes 1 clock cycle. And this is again a memory transfer, right? This is a memory transfer. As it is a memory transfer, it is memory to, register to memory transfer. Which also takes 3 clock cycles. It is a register to memory transfer. It is to and from. Either it could be memory to register, or it could be register to memory. Takes 3 clock cycles. This is also the same operation, which takes another 3 clock cycles. This is 1 clock cycle. This is 3 clock cycles. Halt we don't consider because it's a system halt. Okay. So now 3 plus 1, 4, 4 plus 3, 7, 7 plus 3 is equal to 10. So in order to execute, a total of 10 clock cycles are needed for the execution, but we need to fetch and decode also, right? Every instruction needed to be fetched and decoded. So here, what is the data given for fetch and decode? For instruction fetch and decode, there will be 2 clock cycles per each word. Okay, per every word, it requires 2 clock cycles. It is not per instruction. So we just count the words. The number of words are equal to 1, 2, 3, 4, 5. Total number of words are equal to 1. 1 plus 2 is equal to 3. 3 plus 1 is equal to 4. 4 plus 1 is equal to 5. 5 plus 2 is equal to 7. Number of words are equal to 7. So 7 into 2 equal to 14 clock cycles required for instruction fetch and decode, plus these 10 clock cycles for each and every instruction, as we discussed just a short while ago. That is a total of 14 plus 10, which is equal to 24 clock cycles required for the execution of this instruction, this program. In order to execute this program, we do require 24 clock cycles. Okay. So option B is the correct option.